Okay, just wanted to do a quick review of measuring with significant figures, and we're going to take a look at a couple of rulers to look at how we measure and how the measuring is based on the measuring device. And we have three different rulers here, ruler A, ruler B, and ruler C, and we are measuring the same object with each ruler. But what is different is the way that the rulers are marked. Ruler A is marked from 0 to 10. So it starts with a 0 centimeter measurement and goes up to a 10 with no actual lines marked in between. When we work with a ruler like that, the best that we can estimate is by dividing up in our mind from 0 to 10 by ones. And we can estimate this here, and if I estimate in my head, that looks like about 5 here, maybe in the middle. So maybe that's about 3, okay? So I might estimate that as being 3 centimeters. Someone else might estimate it at 2 centimeters. That is the best we can do. It is marked to the 10, power of 10, 10 to the 1 place. The best we can do is to estimate it to the ones. That is the most accurate estimate that we can make with that ruler. Now, we don't often run into rulers like this that would be so big for measuring something so small. It would be like trying to measure the distance across this room using your car. Your car doesn't measure to the nearest foot, it measures to the nearest mile or tenth of a mile, and it would be pretty silly to try to use your car to measure the size of your desk, for instance. However, we do run into situations like ruler B. Ruler B is marked to the nearest 1 centimeter. But we can see, when we look at this, we can clearly see that this particular object is a little bit bigger than the nearest centimeter mark. It's above 3, and you and I can clearly look at that and see that. And so we want the world to know that we can tell we've got more than 3. So we estimate always with our measuring device one place beyond the marking. So this was marked to the nearest ones, which was 3 centimeters. One place beyond would be to the nearest tenth. In your imagination, you divide the space up into 10 equally spaced things. Some people might say that look like 3.1. Some people might look like 3.2. To some people, that might even look like 3.3. As long as you have estimated to the best of your ability and gone enough places, these are valid measurements. Okay? These are invalid since, although we know it's at least 3, we can do better, right? We always want to do the best we can. This is too far because we really can't tell. We can't even decide between 3.1, 3.2, and 3.3. We really can't go to another decimal place. And again, it's not right on a 3.20 line, and I'll have more to say about that as we go further and work in lab, why we might want to use a 0 at some points. But at this point, we really can't be any more valid than 1 decimal place. Our last choice here with ruler C, our last choice, let's get that back up there. With ruler C is marked not only to the nearest 1 centimeter, but also to the nearest tenth of a centimeter, which means we should be able to now estimate one place even further. And it is a little tricky here to see. I'm trying to get the line to come up here. Smart boards are sometimes a little difficult. Okay, according to the original sheet that this was printed on, this really should be at 3.2 or a little above 3.2. Let's say it's right about there. Okay, so 3.2, you'll notice that all of the measurements over here have that 3.2. You know that for sure because you can see it on the measuring device. What's different about these 3 measurements is the estimate. Because one person, again, is estimating it, it's just a little over the line, the next person a little further, 3.22, and the next person says it's right on the 3.2 line, and for us to know that, we would say 3.20. And so that's how we do significant figures when we are measuring. And then once we have our measurements done correctly in significant figures, we'll go on later to calculate using those same significant figures. But the first step is always measuring in significant figures. Just to go over here, this one is not accurate enough because that implies that we estimated this one when we actually had a line that measured that one. And these two are going way too far. We can't really see that well. We don't have a marking here to estimate here. We don't have a marking here so that we can estimate here. So again, you go just exactly one place beyond what's marked on the measuring device. This was marked to 10, we went to the ones. This one was marked to the ones, we went to the tenth. And this one is marked to the 10th, and so we go to the hundredths place. And that's how you measure with significant figures.